If you sold your 1985 Kawasaki Ninja or Honda VF1000R in the last decade, you just made one of the most expensive mistakes in motorcycle history. And you're not the only one. Right now, collectors are paying $40,000 plus for bikes that sold for $8,000 new. But it's not just about money. Engineering experts are calling these machines the last pure performance era, before emissions regulations neutered everything. Built on analog precision before computers took over, these engines delivered raw power that modern manufacturers legally can't match. We're talking about 150-plus horsepower from naturally aspirated engines that weigh 200 pounds less than today's equivalents. The numbers are staggering. A 1984 Honda VF1000R still outperforms most 2024 superbikes in power-to-weight ratio. So if you're wondering why vintage bike prices are exploding while new ones sit on showroom floors, here's what the industry doesn't want you to know. Here are the 15 engines from the 80s that prove modern isn't always better. Hit subscribe now and drop a comment telling us which of these legendary machines you've owned. But before we start, the 1980s represented the golden era of motorcycle engineering, a time when performance reigned supreme without the stranglehold of modern emissions regulations. Japanese manufacturers operated with virtually unlimited R&D budgets, leveraging their industrial partnerships to access aerospace-grade metallurgy that's simply unavailable in today's cost-cutting environment. Engineering teams worked with a singular focus: maximum power per cubic inch. Nothing else mattered. These weren't just motorcycles. They were statements of engineering prowess. Manufacturers built engines with massive safety factors using materials and techniques that today's bean counters would immediately reject. A crankshaft from a 1985 Suzuki GSXR 750 wasn't just adequate for the job. It was overbuilt to withstand forces far beyond what the engine could ever produce. This wasn't wasteful. It was the philosophy that created legendary machines that still run perfectly 4 decades later. By the end of the decade, naturally aspirated 80s superbikes were producing over 150 horsepower while weighing 400-plus pounds less than their modern counterparts. The 1989 Suzuki GSXR 1100 achieved power-to-weight ratios that current leader bikes, despite 40 years of supposed advancement, simply cannot match. These weren't just street machines. They dominated professional racing for decades afterward. Even now, in vintage racing classes, these 40-year-old designs humble much newer machinery. The cultural impact was seismic. These machines defined what a superbike should be: raw, mechanical, and uncompromising. They created the template that modern manufacturers still reference, even as regulations force them further from the original vision. The sound of a 1986 Yamaha FZ750. At full throttle, represents a mechanical symphony that electronic engine management and catalytic converters have permanently silenced. The introduction of Euro emission standards marked the beginning of the end for true performance motorcycles. Manufacturers suddenly found themselves prioritizing compliance over performance, creating lean burn engines that run hot, lack throttle response, and sacrifice the rich, fuel-heavy mixtures that made 80s bikes so responsive and powerful. Modern liability concerns eliminated the build-it bulletproof mentality that created legendary durability. Where 80s engineers overbuilt everything, modern designers calculate exactly how thin a component can be while still surviving the warranty period. Cost-cutting measures replaced solid engineering with planned obsolescence. Hollow camshafts and powdered metal components became standard, creating predetermined failure points that would have been unthinkable in the 80s. Perhaps most damaging was the transition to electronic complexity. Modern motorcycles became black boxes, requiring dealer software for even basic maintenance. The mechanical transparency that allowed any competent enthusiast to rebuild an 80s engine has been deliberately engineered away. The numbers tell the devastating story. When measured at the rear wheel under real-world conditions, modern superbikes actually produce less usable power than their 80s predecessors. The dyno charts don't lie. Modern bikes show impressive peak power numbers, but can't sustain them due to heat management issues and emissions controls. Maintenance costs have skyrocketed by 400%, while reliability has plummeted due to fragile components and impossible-to-diagnose electronic systems. A complete engine rebuild for a 1985 Kawasaki GPZ 900R costs around $500 in parts and takes a weekend in your garage. The same job on a modern equivalent requires $5,000, dealer-specific diagnostic equipment, and factory training that independent mechanics simply don't have access to. Internal documents from major manufacturers reveal a disturbing truth. They knew exactly what emissions regulations would do to performance motorcycles. A former Honda engineer admitted, "We had to choose between making engines that performed and engines that passed emissions tests." The industry collectively decided that electronic band-aids could replace mechanical precision, fundamentally altering the soul of performance motorcycles. The strategy was threefold. Replace robust mechanical systems with complex electronic controls that could manipulate emissions during testing. Substitute lightweight, fragile components for the heavy-duty materials that made 80s engines indestructible. And prioritize marketing specifications over real-world performance and longevity. Most insidiously, manufacturers created dependency on dealer service through proprietary diagnostic systems. The rider, who could maintain every aspect of their 80s superbike, now needed dealer intervention for even basic adjustments on modern machines. This wasn't accidental. It was a calculated shift to create recurring revenue from service departments. The implementation was systematic. Timing chains replaced gear-driven cams to save $50 per engine, while creating catastrophic failure points when they inevitably stretch. Water cooling systems added complexity and multiple failure modes that air/oil cooling had eliminated. Ride-by-wire throttles introduced lag that destroyed the instant connection between rider input and engine response that 80s bikes were famous for. The marketing departments worked overtime to convince riders that these were advancements, but experienced mechanics and riders immediately recognized the compromises. What was presented as progress was actually regression disguised by electronic trickery and glossy brochures. The market's reaction was swift and definitive. Vintage motorcycle values exploded as riders discovered modern bikes couldn't match the visceral experience, reliability, or even performance of their 80s counterparts. Professional mechanics began refusing to work on modern engines due to diagnostic complexity and proprietary parts that required expensive dealer tools. Track day organizers noticed a curious trend: 80s bikes consistently outperforming modern machines in real-world conditions, especially when ambient temperatures rose above 85 degrees. Modern bikes with their lean burn engines would overheat and go into protective power reduction modes, while 80s machines continued producing full power lap after lap. Social media exploded with dyno comparisons showing 40-year-old engines producing more usable power than current models. The comparison videos went viral. A 1986 GSXR 1100 showing stronger mid-range power and better throttle response than its 2024 descendant, despite the newer bike's theoretical advantages. The numbers tell the story. Vintage 80s superbike prices increased 300 to 500% as demand outstripped supply. A perfect 1986 Suzuki GSXR 750 that sold for $3,000 in 2010 now commands $15,000 to $20,000, while modern motorcycle sales declined as word spread about reliability issues and performance compromises. Independent testing revealed the true performance gap. Head-to-head comparisons between a 1986 GSXR 750 and a 2024 GSXR 750 showed the older bike winning in real-world power-to-weight scenarios, especially when tested in high-temperature conditions that modern engines struggle with. The financial impact on manufacturers has been devastating. Major brands lost market share to vintage bike restoration businesses and specialty builders focusing on mechanical simplicity. Warranty claims on modern engines skyrocketed due to premature failures of cost-reduced components, creating an unexpected financial burden manufacturers hadn't anticipated. Dealer service departments became profit centers, as modern bikes required constant electronic updates and repairs. A modern motorcycle now spends more time in the service department in its first year than an 80s bike would in a decade of ownership. The market's response was telling. Collectors began hoarding 80s engines, driving prices beyond the reach of average enthusiasts. Original parts became worth their weight in gold as riders recognized their irreplaceability. Aftermarket companies pivoted to supporting vintage machines rather than developing modern performance parts, recognizing where the passionate customer base had shifted. Racing organizations created separate classes for 80s bikes because they were embarrassing modern machinery in open competition. Vintage racing classes that were once seen as nostalgic entertainment suddenly became the fastest and most competitive groups at track days. Within the industry, engineering talent fled to companies building retro-styled bikes with modern reliability. Several manufacturers quietly began reverse engineering their own 80s designs for heritage models, tacitly acknowledging the superiority of these earlier approaches. The performance motorcycle market split between expensive modern complexity and affordable vintage superiority, with the middle ground largely abandoned. First, manufacturers chose compliance over performance. Emissions regulations forced lean burn combustion that runs hot and lacks power. These modern engines sacrifice durability for emissions compliance, creating expensive maintenance nightmares for owners. Compare this to 80s engines that ran rich, cool, and lasted hundreds of thousands of miles with basic maintenance. The difference is immediately apparent in throttle response. An 80s carbureted bike responds instantly to throttle inputs, while modern ride-by-wire systems introduce a perceptible delay that disconnects the rider from the machine. Second, they replaced mechanical precision with electronic band-aids. Gear-driven cams that lasted forever were replaced with timing chains that stretch and fail. Simple carburetors with instant throttle response gave way to fuel injection systems with electronic lag. Hydraulic valve lifters that eliminated manual adjustments were abandoned to create dealer service revenue through scheduled valve clearance checks. These weren't advancements. They were compromises that favored manufacturing cost over engineering excellence. Third, they prioritized profit margins over engineering integrity. Solid steel components were replaced with hollow, lightweight parts that fail under stress. The massive safety factors that made 80s engines bulletproof were eliminated through computer modeling that calculated the minimum acceptable material needed. Manufacturing moved from precision machining to cost-optimized casting that creates weak points. A connecting rod from a 1988 Honda RC30 is a work of art. Its modern equivalent is an exercise in cost reduction. Number 15. Suzuki GSXR 750, 1985 to 1987. The original GSXR 750 redefined what a sport bike could be. Weighing just 388 pounds wet with 106 horsepower, it created the modern sport bike template. Its oil-cooled inline-four featured flat-slide carburetors and an incredibly over-square bore/stroke ratio that allowed it to rev to 11,000 RPM. Unheard of reliability at those speeds for the era. What made this engine legendary wasn't just its power, but its engineering. The crankshaft was forged from a single piece of chromoly steel and massively overbuilt. The connecting rods used aircraft-grade materials with tolerances measured in microns. The cylinder head featured porting that took lessons directly from Suzuki's Grand Prix experience. Mechanics still marvel at how these engines can be disassembled after 100,000 miles, showing minimal wear on critical components. The oil cooling system was brilliant in its simplicity. No water pump to fail, no radiator to leak, just an efficient oil circulation system that kept everything at optimal temperature. Modern Suzuki GSXR 75 OHS might show better peak power numbers on paper, but they can't match the flat torque curve, mechanical reliability, or heat management capabilities of these early models. That's why pristine examples now command $20,000 plus at auction, more than 3 times their original selling price. Number 14. Honda VF1000R, 1984 to 1986. Honda's technological masterpiece featured the world's first production 5.4 with gear-driven cams, a system so reliable that many are still running perfectly 40 years later. This engine produced 122 horsepower at 10,000 RPM with perfect primary balance that eliminated vibration. The 90-degree V4 configuration created an engine that combined the best aspects of a V-twins torque with an inline-four's top-end power. What made this engine special was its titanium connecting rods, technology borrowed directly from Honda's racing division that wouldn't appear in production motorcycles again for decades. The gear-driven camshaft system eliminated the possibility of timing chain failure and maintained perfect valve timing even at extreme ERPM. The engine was so overbuilt that professional tuners routinely extract 150-plus horsepower from these engines with basic modifications, and they still deliver 100,000-plus mile reliability. Honda's later decision to abandon gear-driven cams for cost-saving chain systems represents everything wrong with modern motorcycle development. Today, a museum-quality VF1000R commands $35,000 plus at auction, more than 4 times its original price. Collectors recognize that this represents engineering that cannot be replicated under current manufacturing constraints. Number 13. Yamaha FZ750, 1985 to 1991. Yamaha's groundbreaking 5-valve per-cylinder design created one of the most efficient breathing engines ever produced. With 106 horsepower from 749 cubic centimeters, the FZ750 featured a forward-inclined engine that allowed for straighter intake ports and better mass centralization. The 5-valve design allowed for smaller, lighter valves that could rev higher while still flowing massive amounts of air. The engineering brilliance didn't stop at the valve design. The one-piece forged crankshaft was so strong that it became the basis for numerous racing engines. The transmission featured close-ratio gears cut from solid billets of chromoly steel rather than the cast and machined gears used in modern bikes. The real magic was in the throttle response. The 34mm flat-slide Mikuni carburetors delivered instant power with a direct connection between the rider's wrist and engine response that fuel injection has never matched. Modern riders experiencing an FZ750 for the first time are stunned by how responsive and linear the power delivery is compared to modern machines. Clean examples now sell for $12,000 to $15,000, a reflection of their engineering excellence and the growing recognition that this approach to engine design represents a high watermark that emissions regulations have made impossible to recreate. Number 12. Kawasaki GPZ 900R, 1984 to 1996. The original Ninja revolutionized the superbike category with its 115 horsepower from a compact 908 cubic centimeters engine. This was the first production motorcycle to break 150 miles per hour, yet it did so with remarkable reliability. The engine featured a 16-valve design when most competitors were still using 8 valves, creating incredible breathing efficiency. What made this engine special was its perfect balance of performance and reliability. The bottom end was so overbuilt that drag racers still use GPZ 900R crankcases as the foundation for 200-plus horsepower turbocharged monsters. The liquid cooling system was perfectly designed, without the overheating issues that plague modern high-compression engines. The plain bearing design, rather than roller bearings, allowed for tighter manufacturing tolerances and better oil film protection at high RPM. Kawasaki's engineers created main bearings so precisely manufactured that these engines regularly exceed 150,000 miles without requiring a rebuild. Today, perfect examples command $15,000 to $20,000, and prices continue rising as collectors recognize the historical significance and engineering excellence this model represents. Modern Ninjas may have more peak power on paper, but they've lost the bulletproof reliability and mechanical simplicity that made the original so special. Number 11. Honda CBR 1000F, 1987 to 1996. Honda's Hurricane represented the perfect balance of performance and reliability. With 130 horsepower from its 998 cubic centimeters inline-four, the CBR 1000F used a classic configuration, but executed it to perfection. The engine featured Honda's legendary reliability while still delivering superbike performance. What made this engine remarkable was its incredible durability. The bottom end featured journals and bearings so precisely manufactured that engine rebuilds were virtually unknown. The cooling system was perfectly designed to maintain consistent temperatures even under extreme conditions, preventing the power-robbing heat management issues that plague modern superbikes. The 6-speed gearbox featured ratios that perfectly matched the engine's power curve, with shift quality that modern bikes still can't match. This wasn't just a high-performance engine. It was designed to deliver that performance for decades of hard use without compromise. These engines regularly exceed 200,000 miles without internal repairs, a testament to engineering that prioritized longevity over shaving a few dollars from production costs. That's why pristine examples now sell for $10,000 to $12,000, more than their original selling price, despite being 35 years old. Number 10. Suzuki GSX-R 1100, 1986 to 1992. The ultimate expression of 80s excess, the oil/air-cooled GSX-R 1100 produced 137 horsepower from its 1,127 cubic centimeters engine while weighing just 434 pounds wet. This power-to-weight ratio wasn't matched by production motorcycles until the late 2000s, over 20 years later. The engine featured massive 38mm flat-slide carburetors that delivered fuel with a directness that electronic injection still can't replicate. The SAT-TS, Suzuki Advanced Cooling System, oil cooling system, proved so effective that these engines could be run at full power for hours without the heat-related power loss that plagues modern machines. What made this engine legendary was its indestructibility. The crankshaft was massively overbuilt, the connecting rods were forged from aircraft-grade materials, and the transmission gears were cut from solid billets of chromoly steel. Professional tuners regularly extract 170-plus horsepower from these engines with basic modifications, and they still deliver 100,000-plus mile reliability. These engines became so legendary that they were the preferred power plant for custom builders for decades after production ended. Today, perfect early oil-cooled examples sell for $20,000 plus, with prices climbing yearly as collectors recognize what was lost when emissions regulations forced manufacturers to abandon these designs. Number 9. Yamaha FZR 1000, 1987 to 1995. Yamaha's Exup-equipped masterpiece produced 145 horsepower from its 1,002 cubic centimeters Genesis engine. The revolutionary Exup exhaust ultimate power valve system created the most flexible power band ever seen on a production motorcycle, with usable torque from 3,000 RPM all the way to its 11,500 RPM redline. The 5-valve per-cylinder design allowed for smaller, lighter valves that could rev higher while still flowing massive amounts of air. The downdraft intake design created a straight shot into the combustion chamber, improving volumetric efficiency beyond what was thought possible for a naturally aspirated engine. What made this engine special was its perfect balance of technology and mechanical simplicity. The Exup system was mechanical rather than electronic, providing perfect exhaust flow tuning without complexity. The engine's internals featured materials and tolerances that would be considered extravagant by today's cost-focused standards. The reliability was legendary. These engines routinely exceed 150,000 miles without internal repairs. That's why clean examples now command $15,000 plus, with rare early models approaching $20,000. Modern riders discovering these bikes are shocked to find that a 35-year-old design still delivers performance that feels thoroughly contemporary. Number 8. Kawasaki ZX-10, 1988 to 1990. Often overlooked but engineering masterpieces, the original ZX-10 Tomcat produced 137 horsepower from a perfectly balanced 997 cubic centimeters engine. What made this engine special was its incredibly compact design. Kawasaki's engineers created an inline-four that was narrower than many twins by clustering the transmission shafts. The engine featured perfect primary balance, eliminating vibration without the need for complexity-adding counterbalancers. The liquid cooling system was so perfectly designed that these engines run at consistent temperatures regardless of ambient conditions, something modern high-compression engines struggle with. What made this engine legendary was its overbuilt nature. The crankshaft was forged from a single piece of chromoly steel with massive bearing surfaces. The connecting rods used aircraft-grade materials with tolerances measured in microns. The transmission featured gears cut from solid billets rather than cast and machined. These bikes were so ahead of their time that they're just now being recognized by collectors, with prices doubling in the last 5 years. A perfect example now commands $12,000 to $15,000, a fraction of what equally significant but better-known models sell for, making them the last great bargain in vintage superbikes. Number 7. Honda CBR 600F, 1987 to 1990. The original Hurricane 600 redefined the middleweight class with 85 horsepower from just 599 cubic centimeters when competitors were struggling to break 70 horsepower. But it wasn't just the power, it was how that power was delivered that made this engine special. Honda's engineers created a perfectly balanced inline-four with a flat torque curve that made the bike accessible to novice riders while still rewarding experts. The 16-valve head featured porting derived directly from Honda's racing program, creating breathtaking efficiency for a production engine. What made this engine legendary was its indestructibility. The bottom end was so overbuilt that engine failures were virtually unknown even in racing applications. The cooling system maintained perfect temperatures regardless of conditions, eliminating the heat-related power loss that plagues modern machines. These engines regularly exceed 150,000 miles without internal repairs, a testament to engineering that prioritized longevity over shaving a few dollars from production costs. Clean examples now command $8,000 to $10,000, with prices steadily rising as collectors recognize this model's historical significance and engineering excellence. Number 6. Suzuki GSX-R 1100, 1993 to 1998. The water-cooled evolution of Suzuki's flagship represented the perfect balance of raw power and usability. With 155 horsepower from its 1,074 cubic centimeters engine, this generation added water cooling while retaining the overbuilt nature of its oil-cooled predecessor. What made this engine special was its incredible versatility. It produced massive torque from just above idle, yet could rev to 11,500 RPM without stress. The cylinder head featured porting that took lessons directly from Suzuki's racing experience, creating incredible breathing efficiency. The bottom end was famously overbuilt, with a crankshaft and connecting rods that could handle far more power than stock. This became the foundation for countless turbo and nitrous projects, with tuners regularly extracting 300-plus horsepower from these engines without compromising reliability. The transmission featured close-ratio gears cut from solid billets of chromoly steel, rather than the cast and machined gears used in modern bikes, creating shift quality that still isn't matched by current production motorcycles. Perfect examples now command $15,000 plus, with prices rising steadily as collectors recognize what was lost when emissions regulations forced manufacturers to abandon these overbuilt designs. Number 5. Kawasaki ZX-7R, 1989 to 2003. Kawasaki's homologation special produced 125 horsepower from its 749 cubic centimeters engine, a number that's impressive even by modern standards. But it wasn't just the power. It was the character of that power delivery that made this engine legendary. The ZX-7R featured a perfectly tuned intake system with 38mm flat-slide carburetors that delivered fuel with a directness that electronic injection still can't replicate. The engine's internals featured materials and tolerances that would be considered extravagant by today's cost-focused standards. What made this engine special was its racing pedigree. Developed specifically for superbike competition, every aspect was designed to deliver maximum performance without compromise. The crankshaft was forged from a single piece of chromoly steel. The connecting rods used aircraft-grade materials with tolerances measured in microns. These engines became so legendary that they were still competitive in racing more than a decade after their introduction, a testament to how overbuilt and advanced they were. Perfect examples now command $15,000 to $20,000, with rare homologation models approaching $30,000 as collectors recognize their historical significance. Number 4. Yamaha FJ1200, 1986 to 1996. The ultimate sport touring engine, Yamaha's FJ1200 produced 130 horsepower from its 1,188 cubic centimeters inline-four, while delivering bulletproof reliability. What made this engine special wasn't just its power, but its incredible durability and perfect power delivery. The engine featured massive torque from just above idle, with a flat curve that made highway passing effortless. The over-square design allowed for excellent breathing and heat dissipation, while the 5-speed transmission featured ratios perfectly matched for brim met to real-world riding. What made this engine legendary was its indestructibility. These engines routinely exceed 200,000 miles without internal repairs, a testament to engineering that prioritized longevity over shaving a few dollars from production costs. The cooling system maintained perfect temperatures regardless of conditions, eliminating the heat-related issues that plague modern machines. The plain bearing design, rather than roller bearings, allowed for tighter manufacturing tolerances and better oil film protection at high RPM. Yamaha's engineers created main bearings so precisely manufactured that major failures were virtually unknown. Clean examples now command $8,000 to $12,000, with prices steadily increasing as riders discover that these 35-year-old machines deliver a riding experience that modern bikes can't match. Number 3. Honda RC30, 1987 to 1990. Honda's homologation special produced 118 horsepower from its 748 cubic centimeters V4, modest by today's standards, but delivered in a way modern bikes can't match. What made this engine legendary wasn't just its power, but its construction. Every single component was hand-built to tolerances impossible in mass production. The crankshaft was meticulously balanced by technicians who spent hours on each unit. The titanium connecting rods were years ahead of their time. The gear-driven cams eliminated the possibility of timing chain failure and maintained perfect valve timing even at extreme RPM. The engine featured perfect primary balance, eliminating vibration without complexity adding counterbalancers. The cooling system was so perfectly designed that these engines run at consistent temperatures regardless of conditions, something modern high-compression engines struggle with. Most importantly, the RC30's engine delivered its power with a linear, predictable character that made it usable on the street and devastating on the track. Honda's engineers created a motorcycle that could be ridden to a racetrack, win the race, and be ridden home, something that's nearly impossible with modern, highly strung superbikes. These machines now command $75,000 plus at auction, a reflection of their limited production, racing success, and the recognition that this approach to engine construction represents a pinnacle that will never be repeated. Number 2. Kawasaki ZZR1100, 1990 to 2001. The fastest production motorcycle of its era, the ZZR1100 produced 147 horsepower from its 1,052 cubic centimeters engine when competitors were struggling to break 130 horsepower. This wasn't just a powerful engine, it was an engineering masterpiece designed for sustained high-speed running. What made this engine special was its incredible stability at high RPM. The crankshaft was so perfectly balanced that these engines could run at redline indefinitely, without stress. The cooling system was oversized to allow for sustained high-speed running without the heat-related power loss that plagues modern machines. The bottom end was famously overbuilt, with main bearings and journals that could handle far more power than stock. This became the foundation for countless turbo projects, with tuners regularly extracting 250-plus horsepower from these engines without compromising reliability. Most impressively, these engines routinely exceed 150,000 miles without requiring rebuilds, a testament to engineering that prioritized longevity over cost-cutting. Clean examples now command $10,000 to $15,000, with prices rising steadily as collectors recognize the historical significance of these engineering masterpieces. Number 1. Suzuki Hayabusa, 1999 to 2007. While technically stretching our 80s theme into the late 90s, the first-generation Hayabusa represents the culmination of everything learned in the 80s performance era, before modern emissions regulations changed everything. With 175 horsepower from its 1,299 cubic centimeters engine, the Hayabusa wasn't just powerful, it was perfectly engineered for its purpose. What made this engine legendary was its incredible versatility. It produced massive torque from just above idle, yet could rev to 11,000 RPM without stress. The cylinder head featured porting that took lessons directly from Suzuki's racing experience, creating incredible breathing efficiency. The bottom end was massively overbuilt, with a crankshaft and connecting rods that could handle far more power than stock. This became the foundation for countless turbo and nitrous projects, with tuners regularly extracting 400-plus horsepower from these engines without compromising reliability. Most importantly, these engines deliver 100,000-plus mile reliability with basic maintenance, a feat modern superbikes struggle to match. Perfect early examples now command $15,000 plus, with prices steadily climbing as collectors recognize that this represents the end of an era. The last superbike designed before emissions regulations fundamentally changed motorcycle engineering. The explosive growth in vintage motorcycle values isn't just nostalgia. It's a market recognition of superior engineering. These 80s motorcycle engines now command premium prices while modern bikes depreciate rapidly. Professional builders are swapping 80s engines into modern chassis to get the best of both worlds. Modern suspension and brakes combined with engines built when performance was the only priority. The performance gap continues widening as emission standards become more restrictive. Modern manufacturers are forced to employ increasingly complex electronic systems to extract performance from engines that must prioritize emissions compliance over power delivery and reliability. The real lesson is profound. Sometimes progress means going backward. When regulations force compromises, older technology can be superior. Complexity doesn't equal advancement when it sacrifices the core mission of maximum performance and reliability. The market always recognizes authentic engineering excellence, even if it takes decades. These 15 engines from the 1980s prove that peak motorcycle performance was achieved before computers took over. They represent the last era when engineers could build exactly what riders wanted, without compromise. Modern manufacturers could learn from this, but regulations won't let them return to these simpler, more robust designs. So which of these legendary 80s engines would you choose to ride today? Comment below with your pick and why modern manufacturers abandoned the principles that made these machines so extraordinary. Subscribe now for more deep dives into motorcycle engineering that the industry doesn't want you to know about.